Gozaic is a global open-source artificially intelligent cloud computing spatial monitoring system. Through geographic correlation of the environment to human health, Gozaic is able to dynamically predict transmission pathways and the impact of diseases on populations. The relationships that Gozaic learns in correlating the environment to human health can be extrapolated to areas without disease data or to emerging infectious diseases we know little about. Initially, Gozaic will only analyze SARS-CoV-2, but will then scale to other diseases. Gozaic portrays the analyzed data on a central website in the form of imagery. This imagery is frequently updated, publicly available, and finds scale. On this website, users can view the most accurate predictions of disease impact as determined by Gozaic. Or users can specify what data sources and models they would like to use to determine disease impact. Gozaic uses the Astrea Earth AI platform to carry out its analysis. Here, we will show an example of how a user could interact with the platform to determine disease impact. First, the user selects the dates they would like to analyze and the filters they would like applied to data, such as filtering for less cloud cover and imagery. The user then selects the data they would like to be analyzed. In this case, we are using Sentinel satellite imagery. A specific region of the world is selected. The filters sort the data, and the data that meets the criteria is portrayed for that area. Users can compare data from different dates to see how what the population experienced during those dates affected their disease impact. Two different data sources are selected to be analyzed. Here you can see the first data source, and this is the second. Next, a model is selected to analyze this data. In this case, we are using the NDVI model to analyze vegetation instead of disease impact. When the disease impact model is available, then users can select that. This model analyzes the data in near real time and portrays the result. The red corresponds to high values for dense vegetation or in future scenarios, disease impact. Green is little or no vegetation, or in future scenarios, little or no disease impact. As wanted, the user can drag the view line to compare imagery. Other researchers have used the environment to predict disease impact. However, this data is not used to the extent that it could be in monitoring systems. Let's hear from another study that related the environment to disease impact.
High seasonal temperatures followed by extreme rainfall, concentrated populations, and a natural disaster are all conditions conducive to a cholera epidemic. This was the case for Haiti in 2010.
The data that we were able to pull together showed that in 2010, it was the hottest summer in 50 years. And then, as if that weren't enough, there was a hurricane that skirted the island, but it dumped the heaviest rainfall in 50 years.
We tried to make an algorithm in a cohesive form to determine the risk. And that basically provided us with the first clues on the risk of outbreak of cholera in Haiti after this earthquake. Then we used the same algorithm with improved satellite data sets from Global Precipitation Measurement Mission after Hurricane Matthew struck that region again. And we were able to, in real time, predict the risk of cholera infection in human population at least 4 weeks in advance. We did the same thing for Yemen. We knew that there is a mass movement of human population due to civil unrest in that part of the world, and then we had very heavy precipitation. And then we immediately started monitoring conditions. And that basically converged to give us a risk on where and when this disease will occur in human population.
I think we can predict and prevent, and I'd like to see that happen very quickly in the next 3 to 5 years. And I'd like to see the satellite system to be part of the regular public health tools so that we can do prediction as well as the tracking of epidemics that's done traditionally now.